Hi guys, today we're going to talk about independent events. So sometimes knowing the outcome of one event tells you absolutely nothing about the outcome of another event. For example, if you flip a coin twice, the outcome of the second flip is independent of the outcome of the first flip. We say that A is independent of B if the probability of A given B is equal to the probability of A. So this says that knowing B doesn't change the probability that A occurs one way or another. By the definition of conditional probabilities, the probability of A given B is equal to the probability of A intersect B divided by the probability of B. So if the probability of A is equal to the probability of A given B, then it's also equal to the probability of A intersect B divided by the probability of B. That allows us to multiply the probability of B over to the other side, and this gives us the definition for independent events. We say that A and B are independent if the probability of A and B is equal to the probability of A times the probability of B. The definition itself is a little non-intuitive, but from the viewpoint of conditional probabilities, you can see where this definition comes from. Also, it's symmetric, so the probability of B is independent of A, and we can also say that A and B are independent. So the formula follows just by dividing A over to the other side, and one gets that the probability of B equals the probability of A intersect B divided by the probability of A, which equals the probability of B given A. To continue our review of set theory as we go along, we're now going to look at the index set. The index set's just the set of indices that we're looking at. So if we have sets A1, A2, and A3, the index set is 1, 2, and 3, because those are the subscripts of A, the set's A's. So if the index set is A, B, C, D, then the collection of sets A sub I, such that I is in the index set, is A sub A sub B, A sub C, and A sub D. And it's convenient sometimes to use this notation so that whenever we want to take the union of all such sets, we can put the union of I in the index set of A sub I. And that's shorthand for A sub A union A sub B union A sub C union A sub D. A lot of times what we've been looking at is I equals the natural numbers. That would be a sequence of sets, A1, A2, A3, A4, and so on, off to infinity. To generalize our definition of independence, we look at an arbitrary index set. So we have A sub I, where I is in an index set, be a collection of events. That collection is independent if for every subset of the index set, we have the probability of A sub j happening for all j and j is equal to the product of the probabilities of the A sub j happening for all j and j. So for example, suppose we flip a fair coin continuously, and we let AI be the outcome of the ith flip. Well, the first flip and the second flip should be independent, but they're also independent of the third flip and the fourth flip and so on. So we have a sequence of random variables which are all independent. The probability that our first three flips are heads, heads, tails is the probability that A1 is H, A2 is H, and A3 is H. But because 1, 2, and 3 is a subset of our index set, in other words 1, 2, and 3 are some natural numbers, the probability that A1 is H, and A2 is H, and A3 is T is just the product of the probabilities. So we can multiply it as the probability that A1 equals H times the probability A2 equals H times the probability A3 equals T, which gives us 1/2 times 1/2 times 1/2, or 1/8. Oftentimes, independent events are confused with mutually exclusive events. So if we flip a coin twice, the event that the first flip is a heads is independent of the event that the second flip is a heads, but they're not mutually exclusive. So mutually exclusive events are things that can't both happen, and we can certainly flip a heads and then flip a heads again. The event that the second flip is a tails is mutually exclusive from the event that the second flip is a heads. We can't have the second flip be a tails and the second flip be a heads, but they're not independent of one another. If the second flip is a tails, then we know for certain that it's not a heads, so if one occurs, it's at the exclusion of the other event. That's all on independent events. I'll see you guys soon.